Good evening, everybody. I know that a lot of people are wondering if today's class is going to hold. Today's class is likely to hold. It's just that we're waiting for more people to join. So if you have joined, please stay. We're still waiting for more people to join. Once it gets to a certain number, then we can start. Discord is down, so we are not able to post the link to this YouTube video now. So we're just waiting for people. Yeah. I know that a lot of people are wondering if today's class.
So good evening, everybody. Yeah, sorry for the delay. We are trying as much as possible to make sure that we have enough people on the live stream before we go ahead. Please, if you can reach out to your fellow colleagues, if you know any of them that you can reach out to, please do inform them that the class is now live. We'll be starting in the next 5 minutes. So please stay tuned. Thank you. When Damala, you can start now. Chikere, Discord is now live, so you can go ahead to send the link to Discord.
All right. Okay. Good evening, everybody. Can anyone hear me? Hello, can anyone hear me?
We can hear you.
Oh, okay. All right, so my name is Oyindamola Abiola. So for today's class, I'll be discussing Ethereum virtual machine. So I think I'll just start now. So the content I'll be discussing is what is Ethereum virtual machine, the opcodes, bytecodes, and how Ethereum virtual machine works, and also deploying smart contracts on the Ethereum virtual machine and also the Ethereum State. So what is Ethereum virtual machine? So Ethereum virtual machine is basically an operating system that is created to run smart contracts, and it is called EVM for abbreviation, and it only understands opcodes and not solidity as most people might believe. So let me start by explaining what virtual machines are. So talking about virtual machines, they are higher operating systems like Windows or iOS, but more. So that means that they basically approximate the computing power of physical machines using the virtual architecture so that they can run on many different types of operating systems and hardware. And also it actually makes them perfect for the decentralized ecosystem. And in simple words, they are like upgraded traditional operating system that we all know and used to. So that is so for Ethereum, it can work across different operating systems, like I said. So that is for the virtual machine. So for opcodes, so when smart contracts, okay, let me just read this. Opcodes are low-level human readable instructions of the program, and all opcodes have their hexadecimal counterparts. For example, M store is OX52, S store is OX55, and smart contracts when deployed are converted to opcodes to be executed by EVM. So when we deploy smart contracts, it gets converted to opcodes because opcodes is what Ethereum virtual machine can understand and execute. And also, okay, yes, to be executed by the opcodes are to be executed by the EVM. So next, categories of opcodes. So we have different categories of opcodes. How EVM stores, how EVM is able to read and execute the smart contract. So we have the start manipulating opcodes, e.g., the pop, push, and also the arithmetic bitwise opcodes, such as and, sub, or these are the bitwise and arithmetic opcodes. And also we have the environmental opcodes, such as caller, core value, number, memory manipulating opcodes, such as mload, mstore, etc., etc. Then storage manipulating opcodes, and we also have the program counterparts related opcodes, and also the alternating opcodes and the arithmetic comparison bitwise opcode. I've mentioned that in line 2. So the next is bytecode. So basically, Ethereum virtual machine stores the opcodes. It decodes opcodes to, it encodes opcodes to bytecodes. That is the effective and efficient way of storing the opcodes on the Ethereum virtual machine. So each and every opcode is allocated a byte to store, because EVM is heavy on storage. So it allocates a portion for each opcode after being encoded to bytecodes. So next, how Ethereum virtual machine works. So every Ethereum node run on EVM to maintain consensus across the blockchain. Ethereum facilitates something called smart contract, a piece of code that is running on Ethereum. Ethereum has two types of accounts, which is externally owned account, also known as EOA, and also the contract account, both of which are treated equally under the EVM. Account abstraction tries to reduce this to just one account, meaning both EOAs and contract account function like each other. EOA accounts are controlled by private key. This is an example is our wallet that we all use to access tokens and cryptocurrencies and the likes. And meanwhile, contract accounts are stored in the smart contract, also known as the wallet, like I said earlier. And the smart contract, which is written in a contract is written, which is written in a smart contract coding, is converted to something called bytecodes. So what this means is that when we create our Solidity smart contract and deploy, they are being converted to opcodes for EVM to be able to execute, to be able to read and execute. And from there, it's being stored as bytecode on the Ethereum virtual machine. So, yes, so for the Ethereum state is a large data structure which holds not only all accounts and balances, but a machine state, which can change from block to block according to a predefined set of rules, and which can execute by arbitrary machine code. The specific rules of changing code from block to block are defined by the Ethereum virtual machine. So basically what this means is that each contract that runs on the virtual machine has their own state, meaning that, for example, let's say you are trying to use your wallet. Let's say, for example, your MetaMask wallet, right? You have a MetaMask wallet and you're trying to make a transaction. So once you make the transaction, the Ethereum state stores the state. The moment the balance and the operations that you performed on the wallet, which is actually stored on the Ethereum state, Ethereum virtual machine. So it stores the state, let me use the current state of your balance on the Ethereum virtual machine. So that is what the first sentence means. Ethereum state is a large data structure which holds not only all accounts and balances, but also the machine state. So that this happens across all the contracts that we have on the Ethereum virtual machine that runs on the Ethereum virtual machine. So and it changes according to the rules of the EVM. So I think that is all I have for this evening. Do you have any question? Does anyone have any question?
Yes, there's a question on the YouTube live chat.
Okay.
It says, what are opcodes?
Oh, okay. So let me quickly go back to it. So opcodes are basically low-level readable instructions of the program. So basically, Ethereum virtual machine cannot understand Solidity code. It doesn't understand Solidity code. So it converts Solidity code to opcode for it to be able to execute the functions of the smart contract. For you to be able to understand it, it has to convert it to opcodes. Does that answer the question? So that means that when the smart contracts are deployed, they are being converted to opcodes so that the EVM can understand and execute the code when functions are being called on the smart contract.
Okay, thank you. That's the only question I can see on the YouTube live chat.
All right. All right, thank you very much, Chikiri. Are we waiting? I think you should wait a bit more.
Yeah, we can wait for them a bit. Please, if there's any question, if you're just joining and you want to, please can you take it back to the first page, that page where you had everything.
Okay.
And then you want to ask anything about what you're seeing on your screen, please feel free to ask because we're here to answer your questions.
Okay, Wayne, there's a question about the smart contract tax, and I don't know if you can like give light about it. So the person is saying, are we supposed to submit it as scanned link for the second tax?
Okay, yeah, okay, sorry. No, they're supposed to submit their supposed to write a simple hello world smart contract and using remix. So they have to submit their remix link.
Okay, thank you. There's another question here. Someone is saying, does this imply that there are different virtual machines for different blockchains?
Sorry, I didn't get that.
Someone is asking that, I think about OP codes, right? Person is saying that, does it imply that there are different virtual machines for different blockchain?
Okay, so basically for Ethereum, we have the Ethereum virtual machine, and also for other networks, we have, if I get the question right, is it about different networks? Is the person asking concerning different networks and their virtual machines?
Yes.
Okay, so we have some networks that actually have their own virtual machine. And for most networks that we are familiar with, such as Polygon, NAMI, and Binance, they are actually Ethereum compatible. So they are very much compatible with Ethereum virtual machine, and some of them actually uses the Ethereum virtual machine because they are either sidechain or like layer 2 protocol. Does that answer the question?
I guess so. Okay, there's another question. Sorry, Don. Is EVM responsible for converting solidity to copy codes and onward encoding to bytecode? Did you get that?
Sorry, I didn't get that.
Is EVM, that is Ethereum virtual machine, responsible for converting solidity to opcodes and onward encoding to bytecode?
Okay, so basically, converting, okay, bytecode is a low-level programming language, which is compiled from a high-level programming language, such as Solidity. So EVM virtual machine is like a application layer to mitigate the conversion of Solidity to opcode. Does that answer the question?
Okay. I think that's all. Okay, so only saying that, can you shed more light on EVM and Ethereum State? Is it Ether now? I think it will be Ether State.
Oh, okay. So for the Ethereum State, is basically having the object, is basically having the current state, the current changes on the Ethereum virtual machine. We have different contracts running on the Ethereum space, right? So it gives you the instant updates of the smart contract running at the same time. We have, like I said, we have different contracts running, and we have different people calling different functions on different smart contracts. Ethereum State gives you the instant, the immediate current state. So for example, let's say you make any transaction, once you check your balance, it gives you the current balance of the token, or let's say the token you have in your wallet. And also say you are using another protocol, it gives you the update it gives you the state, the present state, the present condition, the present update, like the present, what's another English word for it? Yes, the present changes on on those contracts. So basically, virtual machine uses Merkle tree as data structure to update and to give the instant state of the Ethereum virtual machine.
Okay, thank you. Someone is saying, how is opcode converted to bytecode? Like, is it possible for ops code to be converted to bytecode?
Opcode to be converted to bytecode? Yes, that is how Ethereum is able to store the opcodes. Ethereum is heavy on storage, and the maximum size of each contract is about 24 kilobytes for each smart contract. So it's really heavy on the storage. So it converts the opcode to bytecode so that they can allocate like its portion for each opcode. Does that answer the question?
I think so. If there's a clarification the person needs, I think they can always reach out on Discord, since Discord
Okay.
is back now. I
Yes.
think that's all the questions we have for now. Let me put on this. Yes, that's all the question we have for now. So in case you have your questions and you didn't drop them here, you can always reach out to us on Discord. We would do well to answer your questions. So once again, we are sorry that we started this class late. It's because of the technical issue we had with Discord. So thank you so much, guys, for attending this evening.
Thank you very much. Oh, yeah. So one more thing concerning the assignment. I got an update that the information on how to submit the assignment is going to be shared soon.
Thank you, then. I think we can call it a wrap.
All right.